All right, this is going to be Algebra 2. We are on Unit 2. We're not really on Lesson 5 because, I mean, it is the 5th lesson that we're doing in this unit, but it's not the normal Lesson 5 in our curriculum. We're just going to do some compact review today. All right, so the first thing that I want to talk about are inverses. So, inverses. So, when I give you a list of values, so if I give you, let me just give you the definition first. So, definition. Think of the x and y change places. Something that you don't need to know, which is kind of cool, you can do it as an aside. If you give yourself any function, so I don't know, give yourself some random linear function, or maybe some function that even looks weird that's linear, maybe something that looks like this. If I flip that over the line y equals x, which looks like that. If I flip anything over y equals x, I have taken the inverse of that function. So reflecting it. So this line is almost perpendicular, but not quite. So if I reflected it, then it would become this green line, which is slightly off like this, and slightly off like this. So if I reflect anything over the x equals y axis, then it is the inverse. Why is that? Can you guys figure out why that is?
Because they change places.
Yeah, they change places. The x went to y went to x, and it's over the line y equals x because y equals x means that everything is the same, which means if I put anything on y equals x, it reflects onto itself. So what this means is if I have a large list of numbers, so if I have a squiggly bracket and I have 1, 2, comma, 3, 2, okay, I'm just going to do a list of 2. Before I even begin review, is this a function?
Sure.
Yes.
Why?
Because x doesn't repeat.
X doesn't repeat. Perfect. Can't say it better myself. Now if I take the inverse, change the places of x and y. So the inverse, so we're going to say it's going into an inverse function. Inverse, and then it pops out on the other side as 2, 1 and 2, 3. All right. That is the inverse. I just switched the x's and y's. Is this a function?
No.
It's not a function for the same reason, for the opposite reason, I guess. It has a repeat x value. Perfect. So what does this mean when I have something that is in an equation? So we did a graph. We did kind of a table. If it was literally a table, it would be really easy if I had x and y, and I had 1, 2, 3, 4, 5, 6. I would literally just switch the columns, and that is the inverse function. But I'm not going to do that because that's way too easy for you guys to memorize. It's just like, oh, just erase this x for the title and erase that y, and then I switch them and I'm done. Too easy. So I want to talk about the equation. So this was all, the graphical was here. This was the graphical, which I won't test. Graphical. This was both of these are kind of tabular, or table. And now we're going to do the equation. So equation, say I gave you the equation, I don't want to do a 3, I want to do just a y equals 2/3 x plus 9. All right, literally use the same definition. X and y change places. You change the places of x and y, so this now becomes x equals 2/3, okay, I don't know why that 3 was weird, 2/3 y plus 9, done. That's all you had to do. Although it's not in the best form, and as you guys kind of saw on the practice test, if I actually take the inverse, it is still in y form. So if I change this back to y form again, you guys can practice doing that. Shove everything over to the left-hand side using correct algebraic skills. So subtract 9, so it'll be x minus 9. Divide by 2/3, which is the same thing as multiplying everything by 3/2. And I get my equation. And if I simplify that, it'll be 3/2 x minus, I guess we'll just leave it as 27 over 2. So far, so good?
I got that x was negative instead of 9. But
Oh, that is... Wait, say that again?
x was negative instead of 9 from...
You are correct. Yeah, that's my error. I was going too fast. So if I actually took the time to move y over, it would be a negative y and a negative x. Wait a sec. I'm not so sure.
Oh, wait.
If I subtract the x...
Yeah, you're right.
Okay. Yeah, I was catching myself too. I wasn't sure. Yeah, make sure that you add and subtract correctly when skipping steps here. So that's inverses. That's one of the main properties of standard f. So maybe you want to label this whole section standard f, because we know the vertical line test and we know how to evaluate for certain values. Can't speak. So that was all of standard f. Standard f. And standard f is function properties. All right. I want to take a look at operations with functions. And you guys all correctly found how to do addition and subtraction, although some people didn't know how to FOIL. So maybe we can do that really quick. All right. I'm going to the next slide. Are we good? Ben? Okay. So this is all going to be standard G. What is going on? Standard G. Standard G is operations with functions. With functions. And before we even get there, some background information for how to FOIL. FOIL. FOIL stands for, do you guys remember the acronym?
First, outside, inside, last.
Yep, first, outside. Oh, I did a double O. Outside. Inner. Last. Why do I rewrite that first letter again? Inner and last. Which means if I had some equation x plus 2 times x minus 3. First means x times x, the first and the first get multiplied to become x squared. And then you do the outside. So outside is going to be the x times the negative 3, which is a negative 3x. And then inner, the two insides, 2 times x is plus 2x. And last is the 2 times negative 3, which is a negative 6. Combining like terms, this gives us x squared minus x minus 6. Fist of 5 for how well we understand FOIL. All right, that's double fives. And so moving on to actually looking at standard G, when I add functions, so if I say, we'll just use the same function over and over. Let's say that f of x is equal to x squared, and we'll say g of x is equal to 3x plus 1. So that means if I'm doing f of x plus g of x, what is that going to be? Well, you guys can yell it out if you want.
X squared plus 3x plus 1.
X squared plus 3x plus 1 is correct. Yeah, you literally just add the functions. Subtraction, division, and multiplication are the same ways. All right. Are we all good on the 4 basic operations for arithmetic between function notation? Nod our head. Not quite. Do you want to see division, Ben, or multiplication?
Yeah.
What would you like to see? Multiplication, division, subtraction?
Well, I know addition and subtraction, but so for multiplication you just use FOIL.
You would distribute, or yeah, FOIL. FOIL is really saying distribute, but yes, FOIL would be how to do it. And that's only if you have a binomial and a binomial. I can't speak. Binomial and a binomial. If I have a monomial and a binomial like I have in this example, if I did f of x, and you guys can write this down with me, f of x times g of x, then I literally just distribute the x squared into the 3x plus 1. This is saying this is saying x squared is being multiplied by 3x plus 1, and then I distribute the x squared to make this become, what is that going to be?
3x to the third.
Plus x squared.
There it is, yeah. Same thing with division. Division is going to be dumb because you can't, well, it's not dumb, but it's not going to be able to be reduced. And normally I'll give you a problem that can be reduced. Do you guys want to practice one that can be reduced? I'm going to have to change up. I'm going to have to give you another function. I'm going to give you, let's say, h of x is equal to 2x squared plus x. So I want to know what is f of x divided by h of x.
Is it the same f of x?
Same f of x, yeah. Were you guys able to simplify it?
Still writing it out.
All right. I'll give you some time.
Are we supposed to use reverse FOIL or something?
Yes, you are supposed to use reverse FOIL or reverse distribute. Do you guys know the name for that? When you undistribute? Starts with an F.
Factor?
Yep. We'll write it in the notes on the side. Reverse distribute. Or to undistribute, this is equal to
Should
factor.
I just leave x squared or do x times x?
It helps to write x times x because then you'll see that when you have two things that are being multiplied, like I have in my notes up here, then you can cross out the x's. They cancel out.
Will I get x times 2x plus 1 on the bottom?
Yep.
Oh, yeah. Are you supposed to simplify that or just leave it as a fraction?
I don't think you can simplify it anymore,
Right.
so you have to leave it like that.
Well, I think it would be like 2x squared plus x.
2x squared plus x? What do you, oh, if you distributed the x? I think this is as simplified as you can get it when you're talking about the fraction. So this would be the answer. Are we all okay with this? Okay, so the new thing that might be, well, it might still be review, I'm not sure, but it's composite functions. And this is still under standard G, but I guess we'll just do a new title. Composite functions. So composite functions, they can look a few different ways, and I think there's only two ways. So let me give you some f and g's. So I'm going to say f is equal to, we'll do x squared again. This should be f of x. f of x is equal to x squared. And we'll make a new g of x. G of x is equal to 3x minus 2. So for composite functions, they can look one of two forms, and I'll just give you both forms and we'll solve them. So they can look like, actually both the forms will be the same. We'll say f of g of x. That is the same thing as f of g of x. These two mean the same exact thing. So when you see a little circle that is not filled in, it doesn't mean multiply, it means of, f of g. And you're dealing with a composite function. And you always start with the rightmost function, or the innermost function, depending on which form you're dealing with. So in this one, the innermost function, you take g of x and plug it into the outer function. Another way of writing this, and I can write this out a little bit, another way of writing this is I'm still doing f of, and since g of x is 3x minus 2, I replace g of x with 3x minus 2. And you can say, well, now that I'm plugging in 3x minus 2 in the place of x, well, x used to be x squared. In the place of x, I write 3x minus 2 quantity squared. And then again, since I did the same notation for this problem, the answer is again the same thing. And this guy is pretty key. When we hit AP Calculus, we need to be able to take derivatives of composite functions. So this will not go away. We'll definitely be seeing him next year. F of g of x. So if you're ever in doubt, always take the rightmost function and put it into the leftmost function. Take g of x, take 3x minus 2, and plug that in for the place of x. Do you guys want to try an example, or should we just continue on? It's up to you two. I'm just going to do a really quick example. So example. I want you to do the reverse. I want you to find g of f. Okay, it needs to be a little bit bigger of a circle. G of f of x. Find that. All right. Do we need more time? Okay, so hopefully, Ben, what'd you get?
3x squared minus 2.
Era, did you get the same thing?
Yes.
Yeah, so the shortcut is 3. I'm just going to rewrite g. I'm going to rewrite my first function, but in the place of x, I'm going to leave a giant empty spot, and I'm going to rewrite the rest of the equation. That empty spot is filled by whatever f is. F is x squared, so 3x squared, and my final answer is just 3x squared minus 2. Perfect. So those are composite functions. And now that we know operations with functions, we are done with standard G. Let's move to standard H. So this is going to be titled Standard H. Wait, do we even have a standard H? I think we just have F and G. I apologize. We do not have a standard H.
So what is it?
So you guys know everything for the test now. Just with that short lesson. I guess the one thing that you might want to be careful of, since there's no standard H, let me undo that. One thing you might want to be careful of is when I ask for things like this, G of F of 1, what am I really asking for? What am I asking you to do? What is the procedure that I want you to do?
Find f of 1 and then put that in as g.
Exactly, yeah. And you can even skip a step since we know g of f of x. We can just plug in 1 into our function here too to save some time since we've already found g of f. So what is g of f of 1?
It's 1.
Yeah. Some things that we already talked about, I need to make sure that we understand. What does the vertical line test do?
It checks whether something's a function.
Yep.
Because if the x is repeated, it won't pass the vertical line test.
That is correct. Other things. I don't see anything. You guys know how to take inverses of graphs, not of graphs, of equations, of tables, lists of values. You know how to do composite functions, operations with functions. That's everything on the test. I don't see anything that you guys don't know after this lesson. All right, cool. Well, that concludes the video then.